Hi, my name is Preston, and today we're going to be discussing DevOps for machine learning, MLOps practices, and tools. So first up, for problem formulation, machine learning systems face unique operational challenges that traditional DevOps practices don't adequately address. This infographic examines MLOps, which is the adaptation of DevOps principles for ML systems, as covered in Chapter 10, DevOps and Code Management of the course textbook. We'll focus on how version control, continuous integration, deployment, and um, configuration management must evolve to handle both code and data dependencies. The scope includes model versioning, experiment tracking, feature stores, and model monitoring, but excludes general DevOps practices that don't require specific adaptation for ML workloads. Moving on to literature review, literature search. Um, so for my research, I found there were three critical MLOps challenges. The first being standardization gap. A comprehensive survey found a large number of organizations lack standardized MLOps practices, and this fragmentation significantly increases maintenance cost and reduces model reliability. Next was hidden technical debt. So ML systems inherently incur technical debt that remains invisible to traditional DevOps metrics. Research shows that actual maintenance code for ML systems typically exceeds model code by a factor of 9 to 1, with data dependencies accounting for a large portion of production incidents. And lastly was organizational misalignment. A study of enterprise ML implementation found a majority of failed ML projects stemmed not from technical limitations, but from a misalignment between data science and operations teams with different success metrics and incompatible workflow tools. Next up, for critical analysis. Traditional DevOps tools struggle with ML systems due to their dual dependency on code and data. While standard CI/CD pipelines test code functionality, they can't effectively validate model performance. Moreover, reproducing ML results requires versioning not just code, but data sets, hyperparameters, and random seeds. Industry approaches diverge significantly. Tech giants like Google and Uber have built proprietary MLOps platforms, while smaller organizations often cobble together open source tools. This fragmentation reveals MLOps as an emerging discipline, still seeking standardization and best practices consensus. So next into evaluation. After analyzing the literature, it's evident that MLOps represents a necessary evolution rather than an optional enhancement. Organizations implementing robust MLOps practices report dramatic improvements in model frequency, reliability, and governance. However, the complexity of MLOps tooling introduces significant learning curves and potential debt. The most effective approaches appear to be a modular architecture that separate model training from serving our infrastructure with automated testing at each stage. Organizations should assess their ML maturity before adopting complex MLOps solutions to avoid overcomplicating infrastructures for simpler use cases. And next, and most interesting, so from the research, the most captivating thing that I found in the development of MLOps is the rise of shadow deployment architectures where multiple competing models run simultaneously in production. Unlike traditional A/B testing, these systems automatically allocate traffic based on real-time performance, creating a evolutionary competition between the models. And that's it. So thank you.